we came out of JP Morgan. We led the blockchain group at JP Morgan leading up to 2016, and we're working on a high-performance blockchain in their R&D group as well as advising on strategic investments. Basically, the goal of Kadena is to provide a platform to really to make kind of business adoption of blockchain platforms something that can finally take off. I mean, this is the potential that everybody sees in blockchain, but there's kind of some key problems that are preventing us from being able to do this. At the time we were at JP Morgan, we were focused on private blockchain and some of the things that we felt were missing from the private blockchain story. Now we've also turned our focus to public blockchain and trying to figure out how we can make a platform, a single application platform where you can have business logic running both in a public or in a private blockchain, depending on how you think about the business problem and you solve the business problem with smart contracts, and then if that involves a token strategy or involves something where you want to use a public blockchain, then you deploy that part there. If, on the other hand, you're dealing with a consortium model or something with like an agent model where you want to kind of like build a network for your company and then be able to kind of have a trustless platform with which to interact with your partners, that's where you want to use a private blockchain. And of course, the two can work together. The things that there's kind of two big problems facing blockchain today. The first one is scalability. And this, most people think of that as a public problem, but it's actually a problem in private networks as well. The public problem is well known, which is it's basically congestion, right? If you go on the Ethereum platform, if you were to design an app that everybody thought was super great, and you try to, and your application becomes successful, it immediately becomes its own worst enemy because it clogs up the network, and you face, even if you can face serious business risk just being able to service all the interest in your highly successful application if you get that far. Now the other problem, and scalability is a problem in private blockchain as well, because what a lot of private blockchain vendors won't tell you is that you can talk about a decentralized system running in a private, or a permissioned environment, but oftentimes you can only run a small number of nodes. You can run maybe like 20 nodes, or you can run 30 nodes. But if you really want to distribute the value proposition of a private blockchain to all the people who might participate in it, you're going to want to be able to add new members and come in and give them full nodes so that they are able to take advantage of the kind of value proposition of blockchain too. And what you'll find in a lot of these networks is that once you get to a particular point, you're going to start telling people, no, you can't run a full private node because you're going to slow down our network. That's scalability and performance and issues like that. The other big performance facing smart contracts is safety. If you look at something like the Solidity smart contract language, we have a situation where like every 3 months a new kind of catastrophic bug is being exploited in production. The most recent one was with the ERC20 tokens, where people were able to create something like a quadrillion tokens out of thin air. It's basically like clockwork now that some kind of regular exploit shows up in an Ethereum-based system. And to a certain extent you can say, well, Ethereum's a system that got adoption, so you're going to find bugs in any system that gets adoption. But I think what we're starting to discover is that they're not going away, that developers are trying harder and harder to write safe applications and they just can't do it. That there's something about the platform itself that makes it inherently insecure. So we set out to solve this problem by offering a complete solution. So the first thing that we wanted to offer is an application platform. And sorry if I drill through this deck, kind of find what I'm looking for here. So the first thing we have is a smart contracts language. And so one of the questions you might ask is, well, why do we have a smart contracts language? Why don't we just use EVM, or why don't we use an existing language that's out there? And the reason why is that I myself come out of building trading systems for enterprise. I built algo trading, agency algo trading networks for about 10 years, and before that I was in exchange software. And towards the end, I built a system that allowed sales traders to actually be able to write algos and deploy those into the JP Morgan production system. Needless to say, that language needed to be safe. Needless to say, if that language had bugs, it would cost JP Morgan's millions of dollars and create reputational risk. But there's a very straightforward way to make languages safe, which is that you reduce what the languages does to only tackle the problem areas that you think are relevant. So in the case of Pact, what do we think those problems are? In Pact, the first thing we want to do is we want to be cognizant of why blockchain is even here. Bitcoin is perhaps the most successful application, the most successful deployment of public key cryptography ever, in the sense that now people have a reason to use public key to be signing transactions and leveraging all the kind of security that comes out of a public key environment. So PAC makes it very easy to do single sig, multi-sig. It allows you to use that to govern your contracts. It allows you to govern assets. It allows you to capture attestation on workflows. And all of that is very easy to do in the PAC language. Second, it gives you a database model so that you can model stuff very quickly and very straightforward. If you have any background in business programming, you probably have a good idea how to model your problem in a database. PAC will let you do that. And then the third thing is PAC is human readable and it's interpreted, so when you write your code, you can actually put that code on the blockchain and go interrogate the blockchain and see the actual code that's running. That code is also very simple, and it's designed to be, just like the trading language we developed at JP Morgan, it's designed to be something that a non-technical user can at a minimum read, and at best, like a more advanced kind of non-technical users could even learn how to write simple smart contracts. This may sound like a kind of a pipe dream that non-technical users would understand smart contracts, but look, even today we have SAFT contracts that specify that the token on Ethereum is an ERC20. That is a highly technical specification that says that the code has a particular shape. We foresee that things like smart contract code will actually end up in contract language saying this is the critical bit of code and this is the assurance we're providing. And then people could take that contract, go into the blockchain, see that the code's the same, and have the assurance they need. So PACT is a very feature-rich language for writing blockchain applications, but it really doesn't focus on anything else than that. It's Turing incomplete. That eliminates even more bugs. So that's PACT. So the question is, with PACT you can write your entire application and you can represent your whole business flow. There's a lot of nice features in PACT for doing multi-step transactions like escrow and things like that. But now that you've got your business application, you've got to think about what you want to deploy it to and what is, and how does what kind of network do you need to really make your application go. So then you want to look at one of our two platforms for running smart contracts. So we have a public blockchain that we're launching that's going into testnet this summer and is launching in December of this year. And that's based on the Chainweb protocol. And the Chainweb protocol takes an old idea in proof of work blockchain, which is this idea of braiding multiple chains together into kind of a rope so that all the chains reference each other. The idea is that two chains are actually stronger than one. Like if it takes a certain amount of hash power to attack a single chain, if you have two chains that reference each other, all of a sudden you need twice as much hash power to take over both of those chains. And what Chainweb does is it generalizes that out to networks of 100, 500, even 1,000 chains. That results in a kind of braided chain structure that has so much security that we can actually start taking down the hash power. But it also linearly increases throughput. So in the sense, if you have two chains, that's twice as fast as one. You can do twice as many transactions in a second. If you have 10 chains, that's 10 times as many. If you have 1,000 chains, that's 1,000 times as many. This gets back to the idea that even if we had a smart contract language that was perfect, if you don't have the scalability, you're going to have too much business risk when you deploy this. So not only that, Chainweb is built on proof of work. Proof of work is a kind of miraculous thing that comes out of Bitcoin. That is the first distributed system ever to be deployed into public and withstand, all the infinite amount of attacks that have occurred on the Bitcoin network. It's resistant to network partition. We think that things like proof of stake are, while very interesting, are kind of radically unproven in terms of being something that would be attractive to hack. So we're sticking with proof of work. And this is a way that we can take care of the congestion problem and provide a platform for running smart contracts on. The other part of our platform is our private chain protocol. This was something actually we did the prototype of while we were at JP Morgan, and we open sourced it while we were there to present to the nascent Hyperledger group, which JP Morgan was a founding member of. Hyperledger ended up being kind of a wholly owned subsidiary of IBM. And so IBM eventually dropped blockchain protocols altogether and focused on kind of an application platform that they're now calling blockchain. This scalable BFT is what there's a CoinDesk article you can find about us where they call it the first real private blockchain, and what that real word means is that it's a single network. It functions like a public blockchain, but because it's a permission membership, it can have fast finality. It's a very fast system. It can do 8,000 transactions per second natively. And one thing to think about when you're comparing private blockchain platforms is when they give you a speed number, one of the things you're going to want to look at is, well, what are you measuring? To give you an example, there are some optimistic architectures out there, such as Hashgraph, that can boast much greater numbers than 8,000 transactions per second. But if you have a background in distributed systems, and if you have a background in how you scale applications, you don't want to look at the best numbers. You want to look at the worst numbers. You want to find out what does the system degrade to in unideal conditions. And what you find is that a system like Hashgraph, if its kind of magical ability to separate everything out doesn't work, degrades to a system that does like 1 transaction per second, as opposed to the 40,000 or 50,000 transactions per second that is advertised. So when we talk about pack numbers, we do a kind of representative database transaction. We do something that is like a UTXO, where you're actually transferring, that's 2 database reads, 2 database writes. We can do that at 8,000 per second, and that's on a single blockchain network, which of course can be scaled in a traditional manner like any other application platform. So that's the minimum performance for kind of a standard application. However, the other thing that Scalable BFT really solves is this problem that when you add nodes to it, it doesn't slow down. And we have measured that 8,000 number running networks of 500 nodes at a time. And it's not that there's no impact when you add more nodes. It's just that you take a transaction that normally takes 50 milliseconds to complete. It goes up to like 70 or 90 milliseconds. And of course, network latency enters into this as well. Lastly, the last thing about Scalable BFT is, as a true blockchain architecture, it means that the entire blockchain flow is auditable. So what does that mean? It means that private blockchain can be, if you're not paying attention to how your network is constructed, private blockchain can be the kind of place where collusion can happen, where you can have kind of an effective 51% attack with who's validating which transactions go into the blockchain. In an architecture like Scalable BFT, you also have an audit log of those things. So right from when the transaction goes into the system to when it's completed, you can audit that, and you have a permanent, unfalsifiable audit record. So something like this is very nice for regulators. The other thing about Scalable BFT is it does offer a version of private channels. I don't know if we have a graphic for that yet. So a Scalable BFT architecture can be something where you're running the blockchain with like different companies, and each of these different companies represent themselves as a encryption key pair for symmetric Diffie-Hellman channels between the different participants. So, and this uses the same encryption technology that's used by Signal and WhatsApp. So the idea is that we have the latest and greatest encryption technology, making it possible to use a single blockchain but not reveal any information, including who sent it, who's receiving it, any information about the contents of the transactions. And then finally, the smart contract language has the ability to handle these kinds of special transactions, so that you can, on a single network, you can both have confidential transactions, but you don't have to do a new deployment or roll out a new chain to also do public transactions or even host a different combination of secure channels. Their addresses, this information is notoriously out of date and inaccurate. In the case of Medicare, this is starting to be a regulatory problem for health insurers. So this is moved quite far along, and we will be making an announcement about next month about the formation of an industry consortium around our pilot that's built on the Kadena private platform consortium model to address this use case. I mean, this is kind of a crazy list, but the other one, the main ones we're working on other than that is we have pilots in insurance, both in reinsurance as well as in property and casualty. Again, some of this is about like being able to, so for instance, if you're an insurance agent, being able to provide transparency to underwriters, but also provide the kind of smart contract automation to clients, so that the clients it's attractive to clients because now you have an automatic way of getting paid. It's attractive to underwriters because they don't have to do that kind of painful process by which the underwriters need to peer into what agents are doing, and this is something that's a huge pain point for underwriters. In the case of reinsurance, that's a very obvious fit for blockchain because a parametric insurance policy is one that's basically governed by some kind of equation or threshold. So you automate that into a smart contract, and once you have that network in place, you can start rolling out new reinsurance products. The other ones in financial services, our background is in payments. The use case we were working at JP Morgan was a network payments pilot. That's what Juno was built for. That's why the private blockchain is a high throughput blockchain, is to be able to handle. It's important to remember when you're talking about private blockchains, and that if you can really talk about actual settlement of 8,000 transactions per second, you can build a network, you can build quite a powerful network. People often bring up Visa and MasterCard. It's important to remember that Visa and MasterCard, while they're kind of optimistically settling transactions in seconds, the actual settlement of that transaction takes days. So moving that to a system that can really handle, something in the order of 8, 10, 12,000 transactions per second and really provide final settlement on that is something that you could build a very powerful financial system around. So the kind of dates are we already have our private blockchain out there. We already have corporate clients using that. Pact is an entirely open source piece of technology. You can download and start building applications in it today. It's very easy to use. And the public blockchain goes into testnet in late summer and launches next December. Thanks for listening.